the nature of electrodes. So what happens? Now we have given a preamble about these three main conditions to be considered before ions are discharged. When we talk about the nature of electrodes, we simply said that nature of electrodes is a phenomenon where certain electrodes influences the discharge of certain ions because they have affinity for such ions. That is to say, they have love or likeness for such ions. So if we have ion A and ion B, for example, and ion B ought to be discharged in an electrolysis of the salt AB, but because we are now using a particular electrode which has strong affinity, strong likeness for ion B, that the electrode will bring about the discharge of ion B instead of ion A. That is what we're talking about. So, electrode, the type of electrode used, will go a long way to determine which kind of ion is being discharged at the electrodes. But there are electrodes that are called inert electrodes. Inert electrodes do not bother themselves with influencing any discharge of ion. That is to say, they are neutral. They don't go into reaction with the ion. They don't have any kind of affinity or likeness for any ion. They are just neutral. They are called inert electrodes. Examples of inert electrodes are platinum and carbon, that is graphite. But other electrodes are likely going to trigger the discharge of the ions they like most. So that is actually what the nature of electrodes can do. And a good example of this kind of phenomenon is when mercury electrode is used. When mercury electrode is used, it can facilitate the discharge of sodium ion. So if we have sodium and hydrogen, whether the sodium is concentrated or not, and that makes hydrogen the best species to be discharged. Because of the presence of mercury, the mercury cathode will not permit the discharge of hydrogen. Instead, it will facilitate and encourage the discharge of sodium ion, such that it leads to the formation of a complex compound called sodium amalgam. So, when sodium combines with mercury, it forms what is called sodium amalgam. So, because mercury has strong affinity for sodium, that is strong likeness for sodium, it will actually influence the discharge of sodium instead of hydrogen. Whether there is distance between sodium or not, whether there is concentration between sodium and hydrogen or not. So mercury will influence the discharge of sodium ion. And that is actually how electrodes, the effect of electrodes can come into play to bring about the discharge of ions. Apart from mercury electrode, another electrode that can also influence the discharge of its ions is copper electrode. So when we have copper electrode used as the anode in the electrolysis of copper 2 tetraoxosulfate 6, in the electrolysis of copper 2 tetraoxosulfate 6, when we have copper anode, we will tend to have copper being discharged instead of the ones that should be discharged. So let us get to explain that better and see what happens when we use copper anode in trying to bring about electrolysis. So let us put down this. We're just going to carefully erase this so that we can have some space. Okay, we have this is electrolysis of copper sulfate. Copper sulfate is blue, so let us take something like that also. So we have electrolysis of copper sulfate. Since we have electrolysis of copper sulfate, ordinarily, if inert electrodes are used, inert electrodes like graphite and platinum, if graphite and platinum are used, then there will be no challenge. But because we now choose to use copper electrode, then this is actually what will happen if we choose to use copper electrode. So let's assume that copper electrode is used instead of the inert electrodes. So we are going to still take blue electrodes for copper to represent copper electrodes. Now, more especially the anode. So using copper anode, so this is plus, that's the anode. So if we are using copper anode, maybe copper cathode also, or any other, but when the anode is copper anode, now this is what happens. As electricity passes into that solution, we are supposed to have copper and SO4 2 minus, 2 plus. We're supposed to have hydrogen plus and OH minus. So normally between hydrogen and copper, copper should be displaced because it's lower than hydrogen. Between SO4 and OH at the anode, the OH should be displaced. This is what should happen at the cathode and at the anode. But at the anode, OH is not displaced. Since OH is not displaced, what then happens at the anode if we are using copper? If we are using copper, this is electrolysis of copper sulfate solution, and we are still using copper anode. So what happens? Because we are using copper anode will not permit the discharge of OH on it. Instead, it will encourage the dissolution of copper ions. So what happens is that copper atoms inside the copper anode will go into solution as copper ions. This is actually what happens there. It will go into solution as copper ions and then migrates to the cathode and gets deposited on the cathode. So this is actually what happens there. Now, normally it is expected that OH will be discharged. It is expected that OH will be discharged there at that anode, and such that this is what happens there. This is a reaction that should happen there, and then later it leads to the formation of oxygen. But that never happens. That is what we are saying. It never happens. So even SO4, in case if SO4 is to go into that reaction too, should it go? It never happens. Instead, what happens is copper atoms actually dissolves into the solution and then migrates to the cathode side and gets deposited at the cathode. That is actually what happens. So the effect of using some electrodes actually matters. So that is actually what we are saying here. So SO4 2 minus actually can go into that as SO4 solid and then 2 electrons. But this also never happens. Instead, what happens is this. This is what happens. So copper atoms in the anode will dissolve into the electrolyte. It will come out of the anode, go into the electrolyte as ions, and then migrates to the cathode and gets deposited on the cathode. And as that happens, the anode will keep diminishing in size while the cathode will keep increasing in size. And that is an example of electroplating method. So this is actually what happens when we use certain electrodes that can influence the discharge of a particular ion over another ion. So this is actually what happens. So with that now, let us proceed. So we've seen what happens when the copper electrode is being used in the electrolysis of copper sulfate. So looking at the second paragraph, what it said is that rather copper atoms from the copper anode go into the solution to form copper ions and migrate to be discharged at the cathode as atoms, because the process of ionizing copper atoms requires less energy. So that is actually what happens. Thus, the anode keep diminishing in size while the cathode keep increasing in size or mass. So this is what happens at the cathode and anode. Let's take a look at what happens there. So this is a picture of what we're talking about. So when we use the copper electrodes during the electrolysis of copper sulfate, the copper anode will diminish in size while the copper cathode will be increasing in size and mass, because copper atoms from the anode go into the solution and of course gets attracted and will be pasted on the copper cathode. So this is one way of purification of copper, and that is actually how the effect of an electrode over ions, over the discharge of ion, is actually seen and carried out. So with that gained, we shall now look at the following STSs for you, dear students. So you have to show your work for these STSs, go through them and take your time to answer the questions, as I want to believe they will help us to be stronger. This is actually to know how far we have gone and how well we are moving. So these are questions for you during this period. So away from that now, let's proceed to our next subtopic, and that is